Hello boys and girls, Mr. Giomini. Wanted to come to you with a video that really ties in nicely with exponents. It ties in nicely with prime factorization. We're talking about greatest common factor, and then we'll eventually get to least common multiple, but let's first really have a firm understanding of greatest common factor. So again, greatest common factor, the largest factor that both numbers have in common. So for instance, let's say I were to give you the following two numbers. Let's say we did 60, and let's say we did 126. Now, some of you may like to do this. I don't really care for this algorithm, but some of you may do this. Okay, let's see. I have to list all the factors now of 60. So I know 1 times 60. I know 2 times 30. I know 3 times 20. Let's see, does 4 go into 60? Yes, it does. 4 times 15. And then we go 5 times 12. And finally we have 6 times 10. Okay, now let's go to 126. Ugh. 1 and 126. 2 because it's an even number. So 2 and I believe that is 63. Let me just double check my math here. 63 times 2, that's 6. Okay, good. Let's see, does 3 go into it? Now, remember, the rule to check to see if 3 is a factor of a number. I add the digits together. So 1 plus 2 plus 6. That equals 9. Now, 3 is a factor of 9, or 9 is a multiple of 3. So we do know 3 goes into it, and 3 goes into it 42 times. Now, will 4 go into it? No. Will 5? No, because it ends in a 6. Will 6 go into it? Yes, because 2 and 3 go into it. That's the rule for 6. If 2 and 3 work, then 6 works. 6 goes into it, I believe. Let's see, is that 21 times? Yes. 5? No, it ends in a 6. 7? No. 8? No. Let's see, just double check here. 8. 126 divided by 8. I'm positive here. That's 1, that's 8, that's 46. No, we're okay, we're safe with 8. 9, yes, same rule for 3. 1 plus 2 plus 6 equals 9. 9 is a multiple of 9, so we know that 9 does go into it, so 9 will go into it. 9, I believe that is 13 times. No, 14 times. 14 times, let's just double check. Always good to double check. 9 times 14, that's 36. Put a 3 up. 9 times 1 is 9 plus 3. 126, good. And now I have hit, I got to make that number 14. I'm going to hit 10, no. 11, no. 12, no. 13, no. We already hit 14, so we're done. Now, I must find the factor, the largest factor, the greatest factor that they both have in common. So let's see here. Well, we can start at the end. But like they both don't have a 60. They both have 126. They both have 30. They both have 63. This has 20, the other one doesn't. This has 42, no. 21, no. 15, no. They both don't have a 12. They both don't have a 10. They both don't have a 14. They both have an but they both have a 6. So the GCF, I'll write the GCF of 60 and 126 equals 6. Now that kind of really was painful. Another way you can do it is this. This is the algorithm I prescribe to. Don't have to do it this way. But if you do it this way, we have to list all the factors. If you miss one factor, you could really throw off the problem. Here, still a little bit challenging. You have to know multiplication facts, but it deals with prime factorization. Now 60. I know that 2 times 30 is 60. So I'm thinking 2. There's a prime number. 30. Well, 30 is 6 times 5. Well, 6 is 2 times 3, right? Times 5. Let's take a look. 2 times 2 is 4. 4 times 5 is 20. 20 times 3 is 60. So if I know my prime factorization, I'm done. 126. Well, I can even do 126 if I want to make a factor tree over here. 126. We know it's, if I want to go 6, it's 6 times 21. We could break 6 up into 2 times 3, where both of these are prime. And we break up 21 into 7 times 3. Both of those are prime. So now we have 2 times 3 times 3 times 7. Now notice I am not using exponential notation. There's a reason why. we need to find their factor pairs. So here, they both have a 2, so there is one pair. So I'll bring those two together make one pair. Like I have a pair of pants at home. Now, nothing else. This has a 2, but nothing down here has a 2, so that can't make a pair. Hey, we have a 3 here and a 3 here. That makes a pair. So that becomes one pair of 3s. Okay, we have a 5 up here, no 5 down here. And since there's nothing else up here, there's no other 3 to pair up with this one. Cross out. So we have 2 times 3 is equal to 6. Same answer. Just 2 different algorithms, 2 different ways to go about it. Let me show you one more. So let's say let's go with 3 numbers. Let's go 3 numbers. Let me think of 3 numbers that might be relatively somewhat. Let's go with 36, 45, and 54. Now, if you want to do it the old way, or not the old way, but one algorithm, I call it the old way because this is what I used to do in school. My teachers didn't teach me the second way. 36 would be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6. 45. Isn't that 1 and 45? We have 2 doesn't go into it because it's even. 3 will because 4 plus 5 is 9. So 3 and I believe 15. 4 won't go into because it's even. 5 will because it ends in a 5. We have 5 in one place, so it's 5 and what is that, 9? 6 won't go into it because 2 and 3 don't go into it. 7, no. 8, no, it's not even. 9, yes, 9 will. And we already have 9, so we're done with that. 54, 1 and 54. 2 because it's even. 2 and what is half of 54? Oh, 27. 3, let's take a look. Add it. 5 plus 4 is 9. Hey, it's just flipped. 5 plus 9, so yes, 3 will go into it, but if we're going 15 times, it's 3 and what is that, 18, I believe? 3 and 18. Will 4 go into it? No. 5, no. 6, yes, 6 and 9. 7, no. 8, no. We already did 9, so we're done. Now, I have to find their greatest common factor. Well, let's take a look. I could start from the back end again if I want. They don't all have 36, they don't have 45, they don't have 54. They don't all have 15, so we can cross out 15. They don't all have 18. These two have 18, but not all of them. They don't all have 27, so I cross out 27. They don't all have 12, cross that out. Hey, wait a minute. They all have a 9. So the greatest common factor, the GCF, for 36, 45, and 54 equals 9. I'm going to show you this newer algorithm. Again, you can use either one. I want you to use the one that you're getting answers correct with and that you understand. It doesn't help to use one that you don't understand. Now again, I'm going to go prime factorization here. In my head I'm saying 36 is 6 times 6, but I know 6 is not prime. But I can break 6 into 2 times 3 and 2 times 3. I tend to like to put the numbers in order from ascending order. So 2 times 2 times 3 times 3. Quick check of this. 3 times 3 is 9. 2 times 2 is 4. 4 times 9 is 36. 45. That's 5 times 9. Wait, 9 is not prime, but 3 times 3 is the prime factorization of 9. So I have 3 times 3, which is 9, times 5. We go 54. That's 6 times 9, but 6 we know is 2 times 3, and 9 we know is 3 times 3. Now remember, we're going for the number that the factor they all have in common. 2, 3, 2. They don't all have a 2 in common, so I'll cross out the 2. I'll cross out this 2. Do they all have a 3 in common? Yes. So even when I have 3 numbers, that's just they all have a 3 in common, so I put the 3 here. Do they have a second 3 in common? Yes, they do. So now I will add another 3. And remember, it's multiplication here. This has no other digits, so we can cross out the 5 here, cross out the 3 here. So 3 times 3 is equal to 9. Notice the same answer. 2 different algorithms. You get to choose. Take care.